right? Am I audible, guys? Hello?
Yes, sir.
Yes,
Yes,
sir, you
sir.
are audible.
Yeah, so which term of the progression is the first negative term? So what we do is that we have A, which is 20, and we have A2 is ours. So this is 76, 77 by, right? So A2 is 70, so D is how much? 77 by 4 minus 20, 77 minus 80 by 4, which is minus 1. So we see that D is negative, right? So this is D and this is A. And we have to prove that which term of the progression is the first negative term. So what we do is that let us equate it to 0. Right. This will tell that what is the term which will be nearly 0. Right.
Yes, sir.
Yeah. So what people do is that they equate it to this. Right. So negative an is less than. So they equate it to this, but let us put it to 0. Right. Then, yeah, so then calculate what would be Rn. So this is 20 plus n minus 1, right? And then into t is how much? Minus 3 by 4 equals to 0. So we have 20 minus 3n by 4 and plus 3 by equals to 0. So this is minus 3n by 4. We take it in the other side. So 20 plus 3 by 4 equals to 3n by 4. So this is how much? This is 83 by 4 and 3n by 4. So 4 cancel and n is how much? 83 by 4. So this is 2 and this is how much? 7 point, right, so 27 point, how much? 2, so 6 and something. 27.66, right? So can this be a term? Right.
No,
Can this
sir.
be a term?
No.
Right. So we can only have, yeah, good evening, Shreyas. So we can only have 27th term and 28th term. Right. So
Yes, sir.
now you guys tell me that which would be the answer. Right.
28 will be the
28.
answer.
Right, because 27th will give you the
More than
number
0.
more than 0. Yes, absolutely correct. So you know that whenever we cross the 27th term, right, whenever we cross the 27th term, then we would get a negative term. So the term which is after the 27th term is 28th term, so as said, this is the answer. Understood?
Yes, sir. Thank you, sir.
Why, thank you. This is my job. So, yeah. Okay, and who just joined? You have corrected your friend, right? And yes, yes. So what about Mira and
Yeah, there is no option for renaming.
yeah? Yes, Shreyash?
Sir, here is no option for renaming. While I am tapping on the name, there is no option coming for rename.
Okay. So, oh, sorry. One moment. Uh, okay. I can also do this. Yes. So it is changed, right?
Sir, his spelling is wrong.
Oh, Shreyash. Yeah. Oh, it is Shreyash, right? Then there should be H. Is this sorry about? Is this correct?
So many people confusing the same problem by my name.
Okay. So now is this correct or am I wrong again?
Yes, sir, correct.
Oh, oh, sorry, sorry. Yeah. Okay. So any doubt in this problem, guys?
No, sir.
Okay. Now let us start the next chapter, which is triangles. Okay. So Let us recall. Oh, what is this? So before we do that, let us recall what we did in our previous class. So let us recall those. So first thing is that whenever we have in the ninth class, what did we learn? So in ninth class, we learned about congruence, right? And what was the congruency? Congruency of figures meant what? Right. So what was the meaning of congruency of two figures? So when the shape as well as the size of the as well as the size of these two figures, right, are equal, then we say that those figures are congruent, right? So if we have one circle and this other circle, so we can see that this radius is not equal to this radius, right? So is this congruent figures?
No,
Are they
sir.
right? Because only their shape are equal, but size not, right? But are these figures similar?
Yes, sir.
Because their shapes are equal, right? So because their shapes are equal, so we can say that, oh, yeah, we will come to that similar figure later, but again in here. So these are two squares. Okay. So let's say this is 3 and this is 12. So you see that these two figures are shape is also same and size is also same, right? So these two figures are what? Congruent. And we have one more figure. Let's say this one and this one. So you see that this is 3 and this is, and let me remind you that this angle is 90 and this is not 90. So we see that these size is equal, right? Sizes are equal, but shape is not. Understood? So these are not again congruent figures. So this was about the congruency of triangle. Okay, and we have one more thing, right? So we have one more thing, and let me, yeah. So similar figures. So whenever we have two figures which has which whose shapes are equal and size may or may not. Okay, so these are called these figures. So we have some let's say triangle, and we have again triangle. So this is 3 and this is 6. These are two equilateral triangles. So we can see that their shapes are equal, right? But sizes are not equal. So this is not a congruent figures, but similar figures. Understood? So this is the main difference between the similar figures and the congruent one. Understood?
Yes, sir. Yes, sir.
Okay. And after that, I want to talk about, yeah. So there are, yeah. So there are two things to follow up about similar figures. So there are two things which come directly with the similar figures, and those are that the first property of similar figure is that the corresponding angles are equal. Okay, whenever we have two similar figures, corresponding ratio of sides are also equal. So these are the two basic properties of the similar figure. Understood? So let's say we have two triangles. Let me take two quadrilaterals. And when I say that these quadrilaterals are similar, so let's say that this is 1, 2, 3, and this is 3, 6, 9, and 12, right? So, and let's say that I don't know. So this is appearing to be a rectangle, but this is actually, yeah. Let me write it that this is 60, this is 60. Just don't bother about these diagrams, because this is not looking to be 60. And let's say that this is 120, okay? And let's say that this is 70, and let's say what is left. So 130, 120 is how much? 130, 120 is 550, 360 minus 250, 1, 1. So the rest would be 1. Okay. So let's say that these two figures are similar, right? So if these two figures are similar, then you see that the ratio of this one and AB by PQ. Okay, AB by PQ is how much? This is 1 by 3. And BC by QR is how much? This is 2 by 6, which is 1 by. And similarly, we see that DC by SR and this is again 1 by 3, and AD by S. So this is again 1 by 3. So we can say that AB by PQ equal to BC by QR equal to DC by SR, and then it is equal to AD by. So this is the first property of the similar. Okay, and the second property is what? That angle A equal to angle B, angle B equal to angle Q, angle C equal to angle R, and angle D equal to angle S. So these are the two properties of the similar figure. Understood?
Yes, sir.
Yeah. So the first thing is that whenever we have two similar figures, Okay, so where did Faz?
So I guess he got disconnected.
Yeah, so as you can see that I'm also getting disconnected. Sorry about that. Today I need to talk to my internet providers. Yeah. So is this understood, guys? Is this clear?
Yes, sir. Yes, sir.
Now let us come to the. So you guys please note it down quickly, and then we'll understand about. We will recall one more important thing which is needed in this. So for the first exercise, first and second exercise, we will need one more, which is important. So you guys quickly note it down, and then yeah, and then talk about it. Whenever you guys have completed noting it down, please tell.
Noted, sir. Can you scroll? Done, sir.
Yeah, so whenever you guys have put it down,
Done, sir. Can you scroll?
yes, Faz and shares you guys also.
Yes, sir. Me too.
Yes, sir.
Now we will recall one thing more, and then we will start talking about theorems. Yes, noted,
Done,
guys.
sir. Done, sir.
Now let us recall one thing about triangles. That let's say I have this triangle, right? So I have this triangle, and how many vertices do this triangle have?
3.
Right? This is A, B, and okay. So and one more thing. Let's see that I have yeah. So let's say that I have this AC base. Okay. So I have AC base and I can have AB base and I can have BC base. So I can have three bases, right?
Yes, sir.
So whenever I choose one base, let's say I choose one base, and then I want to draw the altitude. So if I choose this AC base, so the altitude would be from which vertices? Yeah. So let's say
A.
that I have chosen this AC base. So the altitude from altitude would be from which vertices? So whatever is remaining, right? I have chosen this base, so the altitude would be from this one, right? What is the altitude? So if we have a triangle, right, and the altitude is drawn from the third vertices, which is perpendicular to the third side, right? This is the altitude, right? Let's say this AD. So AD is the altitude. AD is the altitude because AD is making 90 degree with this BD, right?
Yes, sir. Yes, sir.
Okay. And let's say that if I choose this AB, right, AB base. So from where I need to draw the altitude. Yeah,
C.
C, right? So I will choose this point, and I can I draw a perpendicular on this AB in here? Yeah, in here can I draw this perpendicular? Just think about it, guys, and can I draw the perpendicular like this, like this, like this? So yeah, yes. Can I draw the perpendicular on AB? Yes. So the answer is that I cannot draw in here, right? Because any point I join that would not be perpendicular to this. So then what I have to do, I have to extend this AB line. Right, and if I extend this line, then I would be able to draw the perpendicular. Is this clear?
Yes, sir. Yes, sir.
Okay, so why do I need this perpendicular, right? Because we know that area of a triangle is how much? This is half base
Into height.
altitude, right? Altitude, yeah, height. Altitude or height. But let's say that if I am given this base, let's say this is 3, right? So then I need this height, ACM, right, to calculate the area. So this is why we need all these altitude. Okay, now let's say that I have, I have this one, this BC as my base, right? So can I draw the altitude from this point such that it is perpendicular on this BC? Yes. Can
No,
I?
sir.
No, right? So again, we need to what? We need to extend.
Extend BC.
Yeah, extend. We need to extend BC and then we can draw the perpendicular point. So this was the preliminary idea or preliminary concept that I wanted to discuss. Is this thing clear to you?
Yes, sir. Yes, sir.
Okay, so if these two things are clear, then now we can talk about theorem 1. Okay, theorem, this is actually 6.1. And this is also called the basic proportionality theorem. Yeah, so today my internet is with bad. Sorry about that. Okay, so where was I? The basic proportionality theorem, right?
Yes, sir.
Okay, so it says that whenever when a parallel line is drawn joining sides of the triangle third side, then this parallel line divides sides in an equal division. And so to understand the statement we need to. So that is why mathematics is very, very important, right? Because these statement is just reduced to, let me just write this. These long statements, we can just write it like this. Okay, so if PQ parallel to BC, then AP by PP is equal to AQ by QC. So how many words did I use? Right, so we can reduce the statement to only these points. So this is the theorem 6.1. Okay, whenever we have a parallel line which is parallel to the third side, right? Whenever we have a line which is parallel to the third side, so it divides the other two sides in equal ratio. Clear?
Yes, sir.
Yes, sir.
No, no, not clear. You guys should ask that why. Why these ratios are right. You should ask me that where is the proof? Why should I accept? Right, guys? Yes. Right. Okay, why you guys are so silent? So you guys note it down and then we will prove it. Okay. Yeah, again, yeah. Change your name, Ashish. Okay, yeah. So you guys please note down and then I will prove this. So you guys understand this statement. Am I audible?
Yes, sir. You are
Yes.
audible.
I guess that I
Noted,
was,
sir.
okay. I was thinking that I'm talking to myself and nobody was replying. Okay, so if you guys have noted it down, so let us we have We have a triangle. We have a triangle. And we are drawing a parallel line. We are drawing a parallel line. Okay, so what is given? Given is that PQ parallel to what? BC. This is given, right? And we need to prove that. We need to prove that what we need to prove that AP by BP, this is equal to AQ by Q. This we need. So the idea is that first we'll use the construction. Okay, one more thing. There's one more thing. There's one more thing that we need to remember. So yeah, I will tell it. I will tell about it. So let me talk about this thing also. That whenever you have, so I forgot to tell. Whenever you have two parallel lines, okay, and let me draw it short. Parallel line, and you draw two triangles like this. So you have one triangle like this, and the other triangle like this, right? So this is A, B, C, and A, B, D. Okay. So this A, B, C, and A, B, D, right? These triangles area are equal. So area of ABC is equal to area of ABD. So this you have learned in your ninth class. So do you guys remember this? Yeah. Do you guys remember this theorem?
Yes, sir.
Yeah. So this is the triangle on the same base and between
And
the
same altitude.
same parallels between the same parallel. Okay. So triangles between the because they are because their altitudes are right. So whenever they are between the same parallels, then their altitude. Yeah, so the theorem is that whenever we have two triangles which are on the same base and between the same parallel, then their area are understood. Okay, so yeah, I wanted to solve this. Okay, now construction. Come back to the construction. So we will construct so we will construct this one, and this one. Okay, and this one. Oh, this is not done. Find this one, and this one. Remember, this is perpendicular, and so we have this is M, and so construction is what? Construction is join PQ and PC and QM and PM. This is the construction. Understood?
Yes, sir.
Okay, now let us use this smaller triangle. So this triangle, this triangle in triangle in triangle APQ. Okay, so in triangle APQ, area of triangle APQ would be equal to area of triangle A. Right. I can also write AQP. So let me write it as AQP. Right. Area of triangle APQ. This is the area. This is equal to triangle AQP. Understood?
Yes, sir.
Okay. Now, so then what will I have? So for triangle APQ, if I choose AP as my base, right? If I choose AP as my base, so this is half base into height, altitude. Altitude is how much?
QM.
Q1. Yes. Good. So Q1. And if I choose AQ as base, so what is my height?
PN.
Okay. So half cancel and we have this AQ. I take it here. So I take this QM in the other side and AQ in this side. So AP by AQ, this is equal to PN by Q. Right. So this part, let us leave it at this part. This is equation. So you guys just check what we need to. We need to prove AP by PB, AQ by QC. So in this equation, what do we have? We have two culprits. So this one, right? So we have got these culprits, AP and AQ, right? And these are the unwanted sides, PN and QN, right? We don't need this. Is that right, guys?
Yes, sir.
So
Sir.
we need to get rid of these PN and QN. So yeah, this is our goal. As of now, this is our goal. So now let us take the other. Let me write it here so that it will be. Let me write it. So now in triangle PQB, right? Because I need a PB. So what I will do is that I will take this triangle. And in this triangle, you see that I have this PB. So in triangle PQB and triangle QCB, because in QCB, I have this QC. So this is why I took these two triangles. Okay, so if I write area of triangle PQB equal to area of triangle QCB. So do you guys agree? Yeah, you guys agree to this? Okay, so where did Shreyash put? Shreyash got disconnected. Yeah, do you guys agree with this?
Yes, sir.
Right? And what is the theorem? What is the rule? So area on the same base and between the same parallels. Right. So we have two parallel lines, PQ and BC, and this PQB and PQC. So these are two triangles on the same base and between two parallels. So that is why these two areas are. Okay, so now they just tell me that what is the area of PQ. If I choose PB as my side base. What is the area or what is the altitude? Let me draw this triangle. This triangle. Okay. So for this triangle, if I choose PB as my base, so what is the height? I will have to take the height from the remaining vertices. So what is the remaining vertices? Yeah. Tejasvi, what is the remaining vertices? If I
B,
take PB,
Q,
I have taken PB and Q, right?
Q,
Q. Q is the remaining vertices. So I have to take the altitude from Q. And what is the perpendicular on PB from Q? What is that? Let me draw the diagram here, then you will be able to understand. So what is the perpendicular on this side from this Q? Yes. Did you find? Did you find the altitude?
mm,
Yeah. What is the altitude, Tejasvi? See, from Q, what is the perpendicular on PB? Yeah, what is the perpendicular on PB from Q? So if I write the answer, yeah, Abhi, you help Tejasvi.
yes, sir. QM.
Faiz, is QM right? And Tejasvi, you think about that. Is QM right?
Uh,
Yeah. Is QM the altitude from Q?
A,
QA is a QA perpendicular on PB. Yeah, what is the perpendicular? So perpendicular on PB, on this PB, right? So we have this PB, I extend this and I draw the perpendicular. So yes, QM is the right answer. Seriously, is this not clear? Yeah, yes, did you understand that?
yes, sir.
Yeah, because we have drawn the QM, right? This QM is perpendicular on AB. So if this is perpendicular on AB, which means that it is perpendicular on this PB, right?
Yes, sir.
So QM. Faiz, understood?
yes, I understand.
And yeah, you tell me that if I choose QC, so QC as my base, so what is the perpendicular? What is the remaining? What did I write? So P. Oh, why did I write QC? PQC, PQC. PQC is the triangle, right? PQ. Okay, this is the triangle, right? This is the triangle between the same parallel and on the same base. You guys, did you guys get the answer? Tejasvi has got disconnected. So Tejasvi, you tell me what is the altitude on QC from P?
B. Okay, so P is
Yeah, P is the right. P is the remaining vertices. So from P, what is the perpendicular on Q? So let me draw the triangle. I have to extend this, and this would be perpendicular. So did you find it perpendicular?
N.
Right? Is this clear?
Yes, sir.
So half are cancel, and we have PB into QM, which is QC into PM. So then what we can do is that we need to find out PN by QM. So we put this QM in the other side and we take QC in this side. So this is PB by QC equal to PN by Q. Right. So now we know that PN by QM is how much? Understood?
Yes, sir.
Okay, so by looking into 1 and 2, we can say that from 1 and 2, we can say that AB by AQ equal to BB by QC. And then by rearranging, so I can take this from here to here and this to here. So this would be AB by BB. This is equal to AQ by QC. So this is what we wanted, right? So if you guys have any doubt, please ask me and please note it down. If you guys have any doubt. Tejasvi and Abhi.
Sir, can you
Yes.
explain the last step?
Last step. So this one.
From both the formulas, yes.
Yeah, so from here you see that Pn by Qm, Pn by Qm. So right hand side is equal, right?
Yes, sir.
If right hand side is equal, which means that
They're
this
both
is
equal
also,
to each other. Yes.
yeah. So AP by AQ is PB by QC, right?
Yes, sir.
So now what I do is that I take this in here, okay, and take this in here. So just rearranging, right? I have 1 by 2, which is equal to 3 by 6. So what I do is that I take 3 in here and I put 2 in here. So this would be 6. So this is also equal, right?
Oh, yes, sir.
1
Yes,
by
sir.
3, 1 by 2.
Yes, sir.
Yeah. So
Understood.
just rearrange. Yeah, just rearrange. Or you can also see in this way that this is in the multiplication, so this would come in division, and this is in division, so this would go into multiplication. So whatever way, right? Yeah, so this was the idea. Okay, you guys have please note it down and please, Tejasvi, do you have any doubt?
No, sir.
Note it down, and we didn't do any problems today, right? So we'll do the problems. First, the concept clearing is the crucial, right? So first, we know the theorems, and then on the basis of these theorems, we'll do the rest of it. Yeah, today would be no work, I think. And whenever you guys have completed noting it down, I would scroll down.
Done, sir.
Okay.
And
Yeah. So please, this part also noted. Yes.
Done,
This
sir.
is also okay. So this is a 6.1. Okay, 6.1 theorem. Let me say it again that whenever we have a triangle, right? Whenever we have a triangle and we draw a parallel line to the third side. So this is PQ, which is parallel to BC. So if we have PQ parallel to BC, then AB by BB equal to AQ by QC. This is the 6.1. Okay, who got disconnected? Abhi got disconnected. So yes, then